So thanks for inviting me to be here today. My name is Dr. Bethany Growns and I'm a cognitive psychologist at the Evidence-Based Justice Lab in the University of Exeter. And I'm going to be giving kind of a lightning overview today on what's actually a pretty complex topic about cognitive bias and cognitive mechanisms in forensic science. So research has been growing over the last couple of decades at the intersection of cognitive and forensic science. Much of this research scrutinizes what's known as cognitive bias in research that generally shows that forensic scientists in many different disciplines can be unconsciously influenced by irrelevant information when they make decisions. But I think it's time to move the conversation in this space beyond cognitive bias for a few reasons. The first reason I think that we need to move the conversation on is that there's a huge disconnect between what cognitive science and what the law means by bias that does create some tension between the disciplines. When the legal system talks about bias, they're referring to deliberate, intentional, and unobjective partisanship. So this basically means that when an expert witness is biased, their judgment has been unduly influenced by the party who hired them or the outcome of potential litigation. When the law talks about bias, they're referring to a professional failure of a testifying expert in not following the duty to their court by remaining impartial. And this is seen in legal systems across the world, from the UK to the US and even to Australia. However, when cognitive scientists talk about cognitive bias, what we're referring to is mental shortcuts that we've developed over tens of thousands of years to help us process the extraordinary amount of sensory information that we receive from the environment around us every second, every day. In a way, these biases or shortcuts are better thought of as cognitive reflexes, which are similar to other reflexes that we have, like knee-jerk reactions, largely unintentional, unavoidable, and unconscious. Broadly, when we talk about bias, we mean the way that humans tend to draw on irrelevant information around us when making decisions. For example, one of the earliest illustrations of this was when psychologists asked two groups of people to estimate the number of African countries in the United Nations. Before they asked for their estimates, they randomly showed one group a roulette wheel that had landed on a high number, and the other group where the same wheel had landed on a low number. Despite the fact that roulette wheels are completely irrelevant to the number of African countries in the UN, people who saw the high roulette number were anchored to that number and gave higher estimates of African countries than those who saw the low roulette number. Similarly, court judges tend to award higher damage amounts in hypothetical injury cases when prosecutors seek compensation than judges not given a monetary value to anchor to. So in this study, judges who received an anchor in a hypothetical case awarded an average of over $1.2 million, while those not given any anchor only elected to award an average of $800,000. And so this is just one cognitive reflex out of many, known as the anchoring effect. And similar things probably happen in forensic science. For example, you could imagine that a fingerprint examiner could be anchored by a decision made by another examiner in an AV fingerprint comparison if they were told what the other examiner's decision was. In forensic science, research has shown that forensic scientists can be just as unintentionally and unavoidably impacted by irrelevant information as any other human decision maker. No one can avoid these cognitive reflexes simply by trying to or trying to be objective. Our brains just don't work like that. However, these cognitive reflexes are not the same as bias in the legal system, the intentional and deliberate partisanship that the legal system refers to as bias. So when we talk about bias, cognitive science, we're talking about a cognitive reflex that happens unintentionally. It's not a personal, professional failure to remain objective. It's an inescapable part of how all of our cognitive systems are built. So going forward, I think it's important that we reframe how we talk about bias in forensic science so that we can make sure that we're on the same page. But I also think it's time to move the conversation on from this topic. It's been very thoroughly covered, and I think there are really many more new and exciting areas that we can move on to at the intersection of forensic and cognitive science. So my own research is situated in a particularly exciting area at the forefront of forensic and cognitive science. Rather than focusing on bias and how forensic scientists may make errors, I explore the cognitive or psychological mechanisms that underpin how forensic scientists make decisions. I explore the psychology, or the how and the why, behind how forensic scientists make accurate decisions, so that we can use this research and knowledge to develop training tools to further improve accuracy and performance. For example, my research has shown that forensic scientists have better statistical knowledge of stimuli within their domain of expertise. In one study, we found that forensic document examiners can better estimate the statistical frequency of handwriting features in the general population than novices. And in another study that we recently just finished running, we similarly found that fingerprint examiners can better estimate the frequency of different fingerprint categories, like specific arches, loops, and whorls in the general population than novices. And these studies have shown that one cognitive mechanism that underpins forensic science is statistical learning, or superior knowledge of statistical information within someone's domain of expertise. So the ultimate goal of my research is to understand how forensic scientists make accurate decisions so that we can use this knowledge to develop training programs or selection tools to help new forensic trainees and even existing practitioners to further improve their own accuracy and performance in their work. One brief example of this is another study that we've just finished running, where we trained both novices and fingerprint examiners to specifically focus on statistically rare features when comparing fingerprints. So we told them to focus on statistically rare features like lakes and bridges, and pay less attention to more statistically common features like bifurcations. So we found that training both novices and fingerprint examiners to use this technique improved their performance in a subsequent fingerprint comparison task. And although this is really early evidence of how cognitive science can be used to improve both performance and procedure in forensic science, it's clear that there's much to be gained from collaboration between forensic and cognitive scientists. So forensic scientists know how to apply scientific techniques and methods to crime scenes and evidence, just as cognitive scientists and psychologists know how to apply scientific techniques and methods to studying the human brain and behavior. This is such an exciting time to be in this research space. There's so much more to be discovered about the cognitive mechanisms that underpin forensic expertise. But to do this, I think the forensic and cognitive sciences really need to come together to explore the human factors involved with forensic science decision making. And ultimately, if we can come together and start speaking the same language about these psychological processes, we can hopefully work together to make forensic science more bulletproof. So I'd just like to say thank you. If you're interested in hearing any more about my research or in collaborating on any new exciting projects you might have, feel free to get in contact with me via email or our website at the Evidence-Based Justice Lab. So thank you for having me, and thank you for listening.